Hello, good morning, good afternoon, good evening to everyone, whatever applies to you. I'm very happy to be able to be here today and to present the RBAT study of EMSA. As you can see here, it is a study that has as a main objective or as a goal, as a vision to standardize and facilitate the approval process. So as I said, just a few words for myself. I am Sifis Papageorgiou. I'm a senior project officer here at EMSA, the European Maritime Safety Agency. Have been working for the agency for the last 12 years and have been actively working on MASS related issues over the last 4 years, more or less. And I am the coordinator of an internal task force that deals with MASS. And what does this task force do? Well, at EMSA, we are focusing on various areas when it comes to MASS. We already had a study called Safe MASS, which you may download on our webpage. But also there are colleagues that work with appropriate digital services related to MASS. So they are preparing, they're paving the way forward for MASS, for the adoption of MASS. We were also involved in the regulatory scoping exercise on behalf of the European Commission. We are about to also launch a study on appropriate competencies for remote control centers and drafting curricula for those, or suggesting curricula. And of course, we are also working with cybersecurity related issues. Today, however, I'm here to talk about the RBAT study. The RBAT stands for Risk-Based Assessment Tool, and has as a main objective to risk assess whether the introduction of an increased new ways of automation is as safe or safer than conventional shipping. The study is conducted by DNV and is separated in 3 parts. At the moment, we are towards the end, or we are drawing towards the end of the second part. The first part has been completed. And the first part was the structuring the framework of the tool. The second part is the risk acceptance criteria and the starting of the software development. And the third part is a lot of software development and testing of the tool. It is important for me to note here that in general, the work of the RBAT, EMSA has commissioned it, the work has been done by DNV. In particular, I want to mention the project management of Mr. Sondre, who is a fantastic project manager, and he has done so far a great job in this project. So going into the details of the RBAT, what are we talking about? In principle, when one thinks of introducing automation, this is not something new for shipping, as we all know. However, and in particular, if we're talking about automation that replaces or is not fully in compliance with the rules, then we have to find some sort of alternative design solution, or we have to consider it as such, and therefore go through Circular 1455 for the approval of such equivalence and alternative designs. Within the 1455, there are typically 2 approval phases foreseen. Now, we see RBAT focusing on the first approval phase, which is the preliminary design. So we're not talking about detailed design here. The ambition as well is to have from the tool a non-binary outcome. This means to be able to identify possible risks and issues further down the road, especially for the preparation of the detailed design. And The way to do it is to not say just yes, no, but of course to make also the submitter think and consider deeply the kind of issues that they may encounter. As one of the stakeholders also said, when we were having early meetings, our goal, or one of the goals, is to facilitate assessing the assessment. So, of course, we also think a lot about administrations and how they have to evaluate and approve at the end, or a third party, but of course the responsibility lies with the administrations to have to approve such new mass concepts or automation concepts, or whatever you want to name them. And therefore it is important that there is a high degree of transparency and usability for these typically quite heavy processes. So how will that look like? What we are foreseeing at the moment, and you can see here in the blue box, that within the blue dotted frame, to be more precise, that this is, or this was, part one of the project. And this is typically a framework that has been built, where the user, the submitter, will go into the tool and will have to provide significant input on a number of issues, starting by defining what is automated and why. And this has been done, that there has been a hierarchical multi-level function map that has been structured, so the tool should be able to understand quite easily what is automated. So and at the same time, this means, of course, also what kind of failures this may lead to. Then the second question is then going into more details of the automation. So how is it automated? So if you want to automate a specific sub-function, for example, that you have to think about the use of automation, what is the involvement of the human operator, what is the automation mode. I'm not going to go into details of definitions here, but in any case, in the project, there has been thinking about what we mean about where the control lies, whether we are talking about active or passive supervision, where is the location, the actual location of the operator, and if this means, for example, the possibility of introducing, if the person is in a remote location, if we are introducing also communication related failures, or the possibility of those in any case. And then as a third step, it is also to define and to review how the system can fail and how it is foreseen to recover. So because we also do know that from a very early stage, there are thoughts about how to provide some sort of recovery. The fourth part, which is outside the dotted frame, is whether it is safe enough. That has been the work of the second part of the study. I will come back to that in a second. For the time being, just in order to also allow viewers to picture this a bit better, we are typically talking about, we want to go into accident scenarios, so into failure modes of the different functions to be automated, and then there has to be an assessment of whether there is a negative effect and what kind of risk level this implies, sort of. And you can see here, for example, in the analysis, there should be a sort of also the possibility of recovery if there's detection of the failure, if not, if there's a successful response, and whether that leads to safe or unsafe conditions and consequences. I will again go back into that, but I will now focus a bit on mitigation, which is the main idea that I would like to present today. And that is because RBAT is suggesting a new way of dealing with mitigation, a new, at least for shipping. This is not something new for other transport modes or industries, but what we saw, especially when we tried to evaluate software systems in particular, is that it is very difficult to predict how often such a system will fail. So typically you use a lot of expert judgment because you simply don't know, but you also don't know how the system will fail, really. And we felt that there is definitely a need to evaluate that and see that with a more analytical approach in the mitigation. So while you typically have in risk analysis, probability and consequence, the proposal of RBAT is to focus more on consequence and mitigation rather than probability and consequence. And what you can see here is that there is a proposal on the table that says that the more independent mitigation layers you put, then the safer the scenario becomes, obviously. And for example, these can be internal mitigation layers, but of course, if we're talking about internal mitigation layers, then the effect cannot be, the effectiveness is not very high. You can see here is it goes to moderate. If we have effective independent mitigation layers, then we are talking in principle about more and more lowering of the risk at the end of the day. And in the typical risk matrix, you will have that this will allow you, even if you have the possibility of a failure that can be catastrophic, you would then need to introduce several independent mitigation layers in order to bring the risk down and in order to have something that is acceptable in terms of risk level. So this would typically look like this, and as you can see here in the bottom, you have, or you should think about normal operation and having some sort of initiating event that takes you out of the of your operational envelope or what is considered safe. You may have, as I said, some sort of internal mitigation layer, and then in the red boxes you have additional independent mitigation layers that should bring you back into some sort of operational mode that is not within the accident conditions, that should not lead to an accident. To conclude, the novelty of the approach here is that, at least for approval bodies and administrations, is to focus in particular on mitigation and not probability. So in the risk analysis, we are talking about how severe, of course, the worst case outcome is, but also that in combination with the effectiveness of the mitigation and the different mitigation layers that are designed with a view of preventing losses. There are specific risk acceptance criteria that have been proposed, and of course the purpose is to bring risk as low as reasonably practical. That is it for me for today. Thank you very much, and hope to see you in the Q&A session.
Thank you very much for the presentation. Do we have any questions from the audience? Yes.
Hi, thank you for that. Thank you for that presentation, Sifis. And also like to thank the chair for allowing me to ask all these questions throughout today. My question for you was, so your presentation was concentrated on risk. Do you see maritime autonomous ships as decreasing the overall risk which the shipping industry poses to, say, the marine environment or even to seafarer lives? So does the overall risk that seafaring or ship operations have inherent in them, does that decrease by usage of technology and specifically by usage of autonomous tech?
Thank you very much for that, for the question. I would say that we have not proven that yet. There are definitely aspirations that the use of technology can reduce the risk significantly. At the same time, I think that we need to be careful on how we implement autonomous shipping or automation. And the reason, or let's say our main concern here, is not so much about functions where we know that a machine, for example, could perform better than the human. I think this is pretty straightforward, that for certain operations this is possible to do, but I think that it is more about control, and it is more about paying attention to whether we introduce different risks. For example, what we see a lot through the introduction of several, let's say, automation systems, is that we assign more and more supervision responsibilities to the human, typically, especially at these early stages of automation. And of course, there are also risks related to that. And we're not saying that, oh, you know, this is very risky, but just we need to pay attention to it, and we need to have ways of dealing with that risk. I hope that answers the question. Thank you.
Yes, thank you. Thank you very much.
Any additional questions? I think then we are at the end of this session. So thank you again very much for the presentation.
Thank you.